All right. Tables and graphs. Sometimes it's a function, sometimes it's a relation. Okay? All a relation is a set of ordered pairs. So every time we see ordered pairs, that whole, remember the pumpkin, the jack-o'-lantern you guys graphed? Okay, that is just a set of ordered. Today we're going to talk about how to tell the difference. Some relations are functions. Is we always look at the input. We've got 1, 1. 2. Okay, our table, okay, looks like 1, 1, 0, 2, 3, negative 2. Okay, and you're going to want to see that because we're sometimes going to have to go from ordered pairs to tables to then our graph. If we graph those 3 points, we've got 1, 1, over 1, up 1, over 0, up 2. But we've got arrows going from X to Y. Okay? No big deal. Now, if we look at our X's, if we look at our inputs, are there any numbers that repeat? Come on, perk up. I know it's Monday morning, but okay, we've got 1, 0, 3. Any repeats? Nope. Therefore, it is a function. Okay? If we look at just our X's and nothing repeats, it is a function. Then it wouldn't be a function. Yep, and we'll get to a few of those. It's not a function. It's just a relation. Okay? Because a function doesn't have any repeats in the X or in the input. Okay? Now, domain and range. Okay? Domain is our inputs. Range is our outputs. Okay? So in this case, our domain, what numbers are in our domain? What's our input? 1, 0, 3. So our domain would be 1, 0. One, 2, and negative 2. These numbers right here are our range. You have that down? A range? Innocent, you got that down? Okay. Alright, so let's look at this guy. Alright, we've got we've got 4 ordered pairs. Okay, our domain is what? Negative 6, negative 3, negative 6, and 3. Our range is 5, 8, 9, and 11. Okay, so to tell if it's a function, do we look at the domain or the range? We look at the domain. Okay, are there any repeated numbers in the domain? There are repeats, so is this a function? No. So we go not a function. Because negative 6 repeats itself in the domain. Therefore, it's not a function. Okay, so this next one, what's my domain? 0.8, 1.2, and 3.5. My range is negative 0.8, 0, and 4. Okay, do I have any numbers that repeat themselves in the domain? No. So is it a function? Yes, this one's a function. Yep, it can still be graphed, but what's going to happen is it's not going to make a line. Okay, we'll talk about the graphs of those here in a little bit. Okay, probably next hour, and being able to tell if a graph is a function or not. Okay. All right, so in number 3, what's my domain? Hello? 1/2, 1.5, 3.5. My range? 1/4, 1 1/4, and 2. Any repeats in my domain? So is it a function? Sure is. Function. All right, number 4. We have a table, right? Let's write it. What they want us to do is they want us to write it as ordered pairs. So the first one is 1, 3. Second one is 2, 4. And the third one is 3, 6. My domain is 1, 2, and 3. My range is 4 and 6. Is this a function? Yep. Function. All right, number 5 is a mapping. So we got to take a peek here at what my ordered pairs are going to be. So I'm going to start with these numbers. 6 goes to 5. Yeah, because there's an arrow that goes to 5. 2 goes to 3. 1 goes to 4. And 0 goes to 3. Okay, so let's write it over here. Domain. Domain is what? 6, 2, 1, 0. Range is 1. Oh wait, no, it's not 1. Sorry. 5, 3, 4. Do I have to write 3 twice? No, it's already in my list, so I don't write it again. Is this one a function? Yep, this is a function. What? Well, we've got 5, 3, 4, and 3. You just have to write the numbers that are included in the range. Okay, so we have 5, 3, and 4. We don't have to write it again. Okay? Because you won't find your ordered pairs just from your domain and your range. Okay? To find your ordered pairs, you're either going to have ordered pairs, a mapping, or a table. Okay? All right. So now we got to go backside. Okay? So just that sheet of paper that's right beside where you're taking notes right now. There's a lot of problems in your assignment that aren't in the notes. Okay? So if we have, which I know you guys have done this lots, y equals 2x plus 5. Okay, we are going to have to make a table And today we will use -2, -1, 0, 1, and 2 to fill out our table. Okay, so what do I do with these numbers? For what? We plug them in for x. So we have, this is our equation we're going to use every single time. So we're going 2 times, what am I plugging in for x? -2 plus 5. So what's 2 times -2? -4 plus 5 is 1. Good. Okay, then the same thing, plug in a -1. So 2 times -1 plus 5. What's 2 times -1? -2 plus 5 is, okay, on your assignment, you have to show this work. Okay, so this, what I'm writing over here, is you showing your work. Okay? So 2 times 0 is plus 5 is 5. 2 times 1 is 2 plus 5? 7. Okay, and then 2 times 2 is plus 5 is 9. Okay, and you should be able to tell if your answers are right or wrong because this should be a pattern. These are all going up by 2's, yep. What if I have, this is a good one. Y equals 4 minus x. Okay, so we've got our table again. -2, -1, 0, 1, 2. Okay, so let's be careful here. We've got 4 minus, what am I putting in for x? No, what am I putting in for x? -2. So 4 minus -2 gives us 6. Good. Because that minus and that minus turns into a plus. Okay, so then we have 4 minus, what's going in for x? -1. We have 5. 4 minus 0 is 4. 4 minus, what's going in for x? 1 is 3. And 4 minus, what's going in for x? 2 is, huh? Oh, I thought I heard 3. And then you guys were scaring me. Okay? So is this so super horrible? No. So the first part of your assignment, they're going to give you tables, and you have to tell if it's a function or not. Okay, so turn to page, what page is that, Bria? Turn to page 20.